Hello guys, welcome back to my YouTube channel. Myself Rakshit, I am from Sri Venkateswara College of Engineering. Today we are going to discuss on moment area and conjugate beam method. First we will move on to introduction. Moment area and conjugate beam method. An overview of two methods for calculating slopes and deflection structures with advantages and the applications. Introduction to the moment area method. What is moment area method? The moment area method is a structural analysis technique that calculates the displacement of the given structure due to the given load and how the moment area method works. The method involves calculating the first moment of the area under the load diagram and then finding the slope and deflection by integrating the moment diagram. When to use this moment area method? This moment area method, which is useful for cases where the load varies linearly along the beam and the cross section of the beam is constant. The definition of the moment area and the conjugate beam are: definition of the moment area method is a technique to analyze the deflection of a beam under a load by using the area of the bending moment diagram. And conjugate beam, the method to determine the slope and the deflection of a beam under a load by replacing the beam with a hypothetical beam with the same loading and obtained by inverting the bending moment diagram of the original beam. Calculation of slopes and deflections by moment area method. The first moment of area. First we have to calculate the first moment of the area of the load diagram and deflection equation. Deflection equation is found by integrating the bending moment equation twice, and we have to draw the elastic curve. The bending moment is found by constructing the elastic curve and taking the derivative. Finally, slope equation. The slope equation is found by integrating the moment equation and derive slope and deflection equation by moment area method. The moment area diagram. The moment area diagram is used to calculate the slope and deflection of the beam. And bending moment diagram. The bending moment diagram is derived from the load diagram as shown in the figure. The elastic curve. The elastic curve is constructed by integrating the bending moment equation as shown in the figure. And next move on to conjugate beam methods and its advantages. First we will move on to the advantages. The conjugate beam method does not require the calculation of first moments of area and hence is simpler and faster than the moment area method. And next we will move on to hypothesis. A hypothesis beam is constructed to obtain the slope and deflection of the original beam under the same loading. Next, supports. The beam is supported in the same way as the original beam, and the loading on the conjugate beam is derived by taking the derivative of the bending moment of the original beam. Derive the slope and deflection equation by conjugate beam method. Similarities. The slope and deflection equations for the conjugate beam are similar to those of the original beam. The solution: the slope and deflection of the original beam are found by substituting the bending moment from the conjugate beam into the slope and deflection equations of the conjugate beam. Applications of conjugate beam method. Simply supported beams applications. The conjugate beam method can apply to simply supported beams with various loadings. Next, cantilever beams. The method is effective for solving cantilever beams with complex loads. Next, continuous beams. The conjugate beam method can be used to analyze continuous beams with a variety of supports and loadings. Finally, conclusion and summary. The similarities, differences and applications. First, we discuss about similarities. The moment area and conjugate beam methods are similar in that both calculate the slope and deflection of a beam under a load. Differences. Moment area method requires the calculation of first moments of area, while the conjugate beam method does not need it. Applications. Both methods have applications for analyzing beams of different geometries and loadings. Thank you guys. Thank you for watching my video. Please do like, share and subscribe to my YouTube channel.